Hi everyone, welcome to Oracle Developer Live, and thank you for joining this session about MySQL Shell, the best MySQL DBA tool. My name is Miguel Araújo, and I'm a software engineer at the MySQL Shell team at Oracle, and I would like to invite you right away to ask any questions you might have during the talk. Use the chat window for Q&A, and we have some experts standing by ready to answer any of your questions. So feel free, don't be shy, and go ahead. I will also try to answer some questions by the end of this talk, if time permits. So let's get started. This is a safe harbor statement. I will show some features coming up next week on the new 8.0.22 release. And I will also show some code snippets, so be just aware that those are just for demonstration purposes. All right, a little bit of context. So MySQL has turned 25 years old this year. It has been out there for quite a while. It's a relational database, as you know. So SQL is the language used to interact with it. And of course, MySQL has a command line client, a simple, very simple SQL shell, which is called MySQL as well, which is used to query the databases using SQL. But MySQL is much more than that. It's not just relational databases. There are many operations that you do with MySQL servers. You have to maintenance, upgrades, user management, setting up topologies of replication or HA architectures. So MySQL is much more than just relational databases. So let me introduce you to MySQL Shell, a modern new command line client for MySQL, which was born, written from scratch at the same time as the MySQL document store, which is the new engine for MySQL that allows you to do schema-less JSON together with SQL. It's a crossover. So it's a NoSQL database, and it also provides you an API, which is implemented in Shell. That is called a XDev API, and in Shell it's implemented in JavaScript and Python. So you can use it within the Shell. So as you know, NoSQL is very tied with JSON documents and JavaScript. So this was one of the reasons why Shell introduced this support on the client for JavaScript, SQL, and Python as well. And it's fully customizable like any new modern command line. So let me show you a little bit of Shell, a sneak peek, just in case you're not familiar with it. So this is how it looks like. I just started Shell. No arguments, no connection to any server, just started. This is the interactive client. As you can see, the prompt is very nice with colors. It's indicating that we are in SQL mode. You can switch to JavaScript very easily by doing /JS or Python by doing /py and back to SQL using /SQL. Let me show you how to connect to an instance. Let me connect to localhost. I have a server running on the default port 3306 and the default X protocol port 33060. So there's no need to specify the port. And as you can see, I'm in. The prompt already indicates that I'm connected to a server. It's very nice. It gives you this information. I'm using SSL, so there's this lock icon. And let me show you how Shell looks like. I'm in SQL mode, so I can do simple SQL. I can switch to JavaScript. Let me I have a schema, world X, to show you a little bit of the XDev API. So as you can see, the message says the default schema world X is accessible through DB. So this DDB object, which has several functions. So let me show you, for example, which collections I have on my schema. So I have the collection, country info. What about tables? Do I have any table? Let's see. I have several tables. How do I get a table? db.getTable, for example, the country table. Now I have this table object. I can run some queries, for example, select to get the information. I can run JSON functions. This is a NoSQL schema. And this is just to give you a quick intro of MySQL Shell. I hope I got your attention by now. So let's move on. And let me tell you that there's much more in Shell than meets the eye. So Shell, it was implemented having in mind to become a DBA and developer toolbox. So like you saw, has support for SQL, JavaScript, and Python. It has auto-completion, very handy, command history. It has a fully integrated built-in help system. So you can access within the shell to help of commands and all the features of it, so you don't have to get out and look for online documentation or whatnot. You have the customizable prompts with colors, as you saw, and the very interesting features of Shell are the APIs and the utilities built in, which I'll talk about later, and it's also extensible. And finally, it's an open source product. Let's have a quick overview of MySQL Shell. You can see the input can be JavaScript, Python, or SQL. You have 3 possible output formats: table, JSON, or tabs. You have batch execution. It's an SQL client. It implements the Xdev API in JavaScript and Python. And it has the APIs I was talking about, the admin API to set up HA and replication architectures. And then there's a bunch of utilities such as import JSON, DBA reports, the upgrade checker, fast logical dump and load, and I will talk about all of this later. Finally, just again, you have the prompt teams, can customize the prompts, you have autocomplete and command history. Just recapping, MySQL Shell implements the MySQL Classic protocol and the MySQL X protocol. The Shell API has utilities for operating system utilities, for example, verify if a file exists or some of those, which directory is Shell running on right now. You have general purpose functions. I'll talk a little bit about it after. You can create reports and create plugins to extend Shell. There's a Credential Manager too that I will talk. The admin API to set up InnoDB cluster, InnoDB replica set, the HA and replication architectures. You can deploy also sandboxes for testing purposes. And the utilities, the ones I was just talking about, JSON imports, dump loading, and so on. All right, let's go now into some details. Let's start with the multi-language support, SQL, JavaScript, and Python again. So for JavaScript, the Shell embeds the full JS engine. We use V8 for that. So you have access to all the core language features in Shell. You can prototype, you can run code interactively within the Shell, as long as you stay with the core language features of JavaScript. Same for Python, we use Python 3.6. You probably noticed that it's very pleasant. The Shell, it's very catchy. It has eye candy. It has this very nice, colorful prompts. You can customize them with state information. For example, on these screenshots that I have here, you can see that I added some tags, for example, production, because that server, it's a production server, or information about the threads running, or how many connections are on that host, and so on. You can customize everything in the prompts. You also have autocomplete, that is very handy and useful. Also command history. And finally, you can set the pager. You can use less or more, or just stick with the default that your system is using. The built-in help system, like I was telling you, it's fully integrated. You can have access to all the Shell functionality, all APIs, all utilities within the Shell. It's very easy to use. You just do /help and the topic that you're looking for information, or /? And for example, in this example here, I'm looking for information about the connect command. And as you can see, it gives you the syntax, description, examples, the arguments that it takes, all information. So all the functionality is available on the built-in help system. Let's move on to the built-in APIs. Shell implements several APIs for managing and interacting with MySQL. So mostly related to DBA tasks. And all APIs are available in JavaScript and Python. And how did we do that? So Shell is mostly written in C++. And all of those APIs and utilities are, of course, written in C++. But we implemented a runtime on which this runtime allows us to expose those functionalities at the same time to Python and JavaScript, and it handles everything, type conversion and so on. So this gives you the flexibility and power of choice. You can pick if you prefer Python or JavaScript to use the utilities, or to write scripts for the MySQL Shell using the APIs. I will show you here now very quickly an example of the API, the database APIs. I picked the classic protocol one, and this is just a JavaScript example. So I use some core functionalities of JavaScript, just print some ifs, and here you can see that this. So this is a script to create just an account, nothing fancy. So you can see here that I use this shell.prompt. This is one of the general purpose functions that I talked about before, and this will prompt a message in shell and wait for input, and then I will store that input in this variable username. And then I will do the same for the password, prompt the password, the users type in the password, store it in this variable, and then I just declare a list of grants. And then I just use the database API using the current session to run some SQL with this run SQL command. And I just run the query to create the user and with the information that I got, and then a simple loop to do again the same to create to run the query to do the grants that I wish. Very simple. This is just a JavaScript example. Could be in Python as well. Something very useful in Shell, very handy, is that you can work with multiple MySQL connections at the same time. You can use the Shell API or the Xdev API to get the session. So you use this MySQL, for example, for classic protocol, MySQL.getSession, and this will return an object. So this is a Python example, and that object is there meanwhile Shell is working in interactive mode, and you can use that object at any time to do operations on it. So here I got two sessions, two different hosts, and I just run some queries on the session. So you can have as many sessions as you would like with these session objects, and you can work with multiple MySQL servers at the same time. Okay, so utilities. DBA focused, several utilities built in the shell: upgrade checker, JSON import, dump and load, session inspector to get information about the current session you have established. This is all exposed on the Shell API util module. Let's go and take a look at the first one that I want to talk about, that is upgrade checker. So as you know, MySQL right now, it's on version 8. We totally recommend that you use it, but there's still a lot of people using 5.7. That was a previous version. And since this is a major, it was a major release, there are several things that change from 5.7 to 8. So there might be clashes, for example, reserved words that are new and you have some schema using them, so you have to change it, otherwise you won't be able to upgrade, or some conflicting settings, or even obsolete settings. And this tool, the upgrade checker, will not take action, but will take a look at your configuration, your schemas, and will give you all the information of what needs to be changed. And then you can perform the changes. This also can check configuration files, and it's available in the util object with this command, the check for server upgrade. I have here an example in JavaScript mode. And let me show you how does it look like. So of course, this is just a portion of the output, because there are more than 20 checks. So I have here just 6, and I'm showing an upgrade from version 5.7.26 to up to the latest MySQL Shell, MySQL version 8.22. And for example, you can see here that it's checking for reserved keywords, names conflicting, or the char set, or if there are partition tables using engines with non-native partitioning. Of course, this was just an empty, clean, just out of the box instance, so there were no issues. It's just to show you how does this look like. I would like to take the moment to talk about the API command line integration. So I've been showing you examples of utilities and APIs being executed in Shell in the interactive mode, which is the one you saw before. But you can also call all of those APIs within the command line. For example, in Linux using Bash, you just call the MySQL Shell binary. You have to follow the syntax that I show here in orange, the shell options, and then using this special delimiter character that is --, everything that comes after that is the API and the options that you want to call. So the object, command, and command options. It's easy to see here on this example. I'm calling the shell binary, connecting to host T480, user admin, and then I do / cluster status and the option extended one. I have here something interesting, some integration. So I was thinking about it, and I thought, for example, automation tools. It's a very good use case for this command line integration. For example, Puppet. Let's say this is just hypothetically. Let's say you have your servers, you have Puppet running, and you want your servers to be always using the latest MySQL version. So Puppet will ensure that. But if you just upgrade right away, you might have clashing options and schema settings that will just break everything. So you want to run the upgrade checker that I just showed you before, right? So how do you do it in Puppet? You use the command line integration. So you call, as you can see here, I have this service MySQL. I ensure that it's always the latest. But before executing it, I call this other, I call it upgrade checker, on which it runs a command that calls the shell using the command line integration, the util check for a server upgrade, and it will run it before executing the upgrade. It's just an example to show you how could you integrate shell and the utilities and APIs with other external tools. Back to Dockstore, importing JSON documents. You can do the importing to collections or relational tables, but that is troublesome and can take some time. If you have to do everything manually, do the multiple inserts or write scripts to automate that. So we have implemented in Shell another utility, which we call import JSON, that will get your JSON document. You select the schema or collection where you want to import it, and it will handle everything for you. It will do it right away. And on top of that, it supports binary JSON data types as well. And of course, it can also be used with the API command line integration, like I show here in this example below. Dumping and loading. So this is something new on MySQL Shell. It's a set of utilities to make it easy to do logical dumps and logical loads of a whole database instance, including users, everything, or just a set of schemas. This, of course, like everything in Shell, was focused on ease of use. So just 3 commands. I show them here: util.dump instance to dump an entire database instance. It includes the users. Or you can just dump a set of schemas or a single schema using dump schemas. And then you can load the dump into a target database using util load dump. This had a really big focus on performance. So it was implemented with concurrent execution and it's multi-threaded. So both dump and the load are multi-threaded, so it's really fast. And it also uses a built-in compression. We use ZSTD and gunzip. So it's really fast. And also, last but not least, it was focused on integration. And integration with what? With the MySQL database service on OCI. So you can dump strictly from into the OCI object storage. You can from your on-premise instance to OCI or vice versa. So it has these compatibility modes for importing into the MySQL database service on Oracle Cloud. This is very handy, and it's really, really, really easy to use. Let me show you some benchmarks so you can see how fast it is. This is some benchmarks that we did for the dump throughput. We compare MySQL dump, MySQL pump, MyDumper, and MySQL Shell dump and load features. So MySQL Shell dump and load is in pink. And you can see, for example, using the dataset of Stack Overflow, which is really big, we could get almost 3,000 megabytes per second, which is huge. It's really, really fast in comparison with other existing tools. There will be a session about this, so please stay tuned and you will know every detail about it. Okay, something very important, replication and high availability. It's a known fact that companies want their data to be always available, so they don't want to lose data. So MySQL provides the technology, it has this technology of replication for a very long time. It provides those individual components to achieve these setups. But of course, it's up to the user to set up those architectures. So just so you have an idea, there are several steps involved. You have to do the provisioning of the instances, restore backups. You have to handle all the user management. You have to do the replication configuration. You have to, if you need, to deploy client proxies. And then, of course, do the manual change of topologies, or even rely on external tools, or write your own scripts to automate things. And then also to monitor the topology and your setup. You have to use additional monitoring tools. So, this was a lot of work for DBAs and sysadmins who spend their time automating these kind of things. And having this in mind, we came up with the admin API, which is also built in the shell, available in JavaScript and Python. And this admin API handles the whole setup and management of InnoDB cluster and InnoDB replica set, which are the HA and replication solutions of MySQL. So the admin API completely handles the complexity of those tasks. It's from configuration to provisioning, the orchestration of the instances, the whole setup of the replication. It handles the creation of users for you. You don't have to worry about anything. It's very simple, very straightforward. It doesn't require any MySQL expertise, but at the same time, it's powerful. You have all the features available if you want. It's secure and it's very flexible. In case you're not familiar with InnoDB cluster, this is the what we call the complete HA solution for MySQL, which is basically the combination of three components. You have the MySQL servers running MySQL group replication, which is the replication technology. And group replication is built using the Paxos algorithm. So it uses a group communication system. So servers in group replication are parts of groups, and each instance knows which ones are part of the group, which ones left, which ones join in. And the most thrilling feature of group replication is that it handles the failover for you automatically. So if, for example, the primary of the group crashes, the others decide to kick it out and elect automatically a new one to become the primary. So this takes away from the user, from the DBAs, the need to do the manual failover. And this is why we call it an HA solution. And then, of course, MySQL Shell with the admin API will handle the whole setup configuration of the architecture. And finally, MySQL Router will handle the traffic from your clients to the right instances. It's a very lightweight component. It understands the topology of InnoDB cluster and knows how to redirect the queries for the right places. So if a query write comes in for writing stuff, it goes to the primary. If it is for only read-only, it goes to the secondaries. MySQL Router handles this all for you. As for a replica set, what we did for replica set is pretty much what we did for InnoDB cluster, but instead of relying on group replication, we use MySQL replication, the classic asynchronous replication. So it's for a different use case. There's going to be a session about this also. So if you want to know more about it, please join it. So this is a simple but complete replication solution as well, since you have the shell to set up, configure everything, router, and the servers running the replication. This is how the admin API looks like. So in 3 commands, very easy, you can set up a cluster. So as I was saying, group replication and replication imply lots of configuration settings, creation of replication users, and whatnot. So in the admin API, you have a command to configure the instance to be ready to be used in an InnoDB cluster. This command will take a look at your instance. We'll check which settings are in place. We'll check which settings need to be changed, which are the requirements for group replication on InnoDB cluster. And we'll present those to you. We'll ask you, do you want me to change those settings? You say yes. And then it will ask you, do you want me to restart the instance? In case some of the settings require an instance, it will do that for you as well. It allows you to create a new administration account for another cluster with a minimum set of grants for managing a cluster. So yeah, you configure instances, then you connect to the one of them, the one on which you want to start a cluster. And using this command called create cluster, you just create your cluster. It returns an object, your cluster object, and it's done. It's very easy. The admin API, as you can see, it's built in this DBA object, which is initialized automatically when shell starts. And you have the access to a whole functionality of admin API. Okay, and then after you have your cluster object, you can add instances to it and build your cluster, and then you have access to a whole set of features, functionalities such as checking the status, removing instances, and changing options, and so on. As for replica sets, pretty much the same. We follow the same syntax, so only changes the name of the command. So in this case, configure replica set instance, create replica set, and then add instance, remove instance. Those are all the same. I would like to show you how this looks like. It's always better to see things in action. So before I've created a cluster that is running on this host. I'll get the cluster object, as you can see, and just to show you the functions available on the cluster object, let me show you the status. So this is the status of my cluster. I call it Oracle Dev Live Cluster. It's okay. It's online, can tolerate up to a failure. And here you have the topology of my cluster. I have 3 instances. This one running on 3310 is the read-write one. The other 2 are the read-only instances. So I have here my cluster. I can do operations. For example, I can check which options are in place. This JSON output shows me the list of the whole options settings of my cluster. You can change those using set option for the whole cluster, set instance option, and you have many other functionalities of the admin API. I would like just to show you how to add an instance to the cluster. So I deployed an instance running on 3370. I will run the configure instance to get it ready. 3370. I'll create a cluster admin, call it admin, and okay, the command started, is asking me for a password for my new account. And now, as you can see in this table, I got a bit stretched because of the font that is kind of big, but you can see that the command is telling that some configuration options need to be fixed. It shows you the current value and the required value, and it's asking if you want to perform the changes, of course. And since some of them require the restart, it asks you, do you want me to restart the instance? Yes, I do. And the admin API takes care of that for you. It restarts the instance, gets it ready. So now you can just add it to the cluster using the add instance command. 3480, 3370. Pretty easy. Password, I can store the password. All right, and so here, what that instance does is to verify the state of your instance. And it asks you, it determines the best recovery method for the instance to join the cluster. And since this one is a completely empty instance, it will ask you if you want to do a clone. And what is clone? So the admin API completely integrates MySQL Clone, which is a plugin for the server to do a full clone of instances. The admin API fully integrates it, and you can use it in that instance. So I'll pick clone, and you can see here the command executing, adding the instance. It will do monitoring. You can see the progress of clone, the transfer, page copy, redo copy. It waits. Then the instance is shut down, it restarts, it waits for the server to restart. You have all this progress information, which is really nice. Okay, clone process has finished, 2.18 gigabytes transferred. As you can see, clone is really fast. And now, using status, you can see that the instance is already here. There's a command to show the topology, which is cluster describe. Very simple, just shows you the topology of your cluster, so you can see it's already here. I also created a replica set, so just to show you, I'll connect to my instance with the replica set. So I get the object, replica set, DBA, it's replica set. Here's my replica set. Same style of commands, same syntax, status, information, the primary, the secondary, information about the applier status, applier thread state, and so on. And you have access to the functionality of replica set here. For example, one thing that it's different in replica set is that there's no automatic failover. So if the primary crashes, if your source instance crashes, you have to manually act and elect a new primary. So you can see here the command to do that, which is force primary instance. So the DBA needs to take action on those cases. Okay, let's move on. As you can see, it really couldn't be easier. It's admin API. It's super easy to use, and it allows these two powerful solutions supported with this shell ease of use. Okay, so now gets back to the shell API. The shell API has these general purpose functions. You've seen some OS utilities, the Credential Manager, and the most thrilling extending MySQL Shell. Let's take a look at first the Credential Manager. Probably noticed that when I was in Shell running commands and connecting to instances, probably noticed that I didn't type the password for some of them, right? And that's because I'm using the Credential Manager. The Credential Manager is functionality in Shell to store the passwords for your connections using a secret store or keychain. This is it has support, built-in support for the MySQL login path. Or if you're using macOS, it uses keychain from Mac, and in Windows it uses the Windows Credential Management API to store and handle your credentials. You can also access which credential helpers are available using the shell.list credential helpers. I was trying this out in a macOS server, so I had access. I had keychain and login path. You can list your credentials. For example, 3 of them here. Of course, passwords are hidden here. And yeah, the Credential Manager is very useful and saves a lot of time when you have to handle a lot of servers. All right, let's move to extending the MySQL Shell. One of the features that makes Shell really a modern client. You can extend it. You can write plugins or extension to the MySQL Shell, and that's available in JavaScript and Python. And you have the whole set of Shell APIs and utilities available for your plugins and extensions. And of course, you can create those in runtime while you're running Shell, but probably what you're going to want is to persist them on disk and then make them automatically loaded at startup with Shell, and that's possible, and that's actually the most common way to do it. Let me show you an example about registering an extension. So we call it reports. So these reports in Shell are called using the /show command and then the name of your report. And you can also do /watch and the name of your report, and watch behaves like in the known watch command in Bash. So it will keep executing in each 1 or 2 seconds the report and show it to you in Shell. So the commands to register a report are available in the Shell object. Register report, create an extension object, add members into it, and then register the extension object as a Shell global object. Let me show you an example in Python. So I just wanted to create a report to get the uptime of my server. So I wrote this query to check performance schema to get the uptime. And then using the Shell API, the MySQL Classic API, I run the SQL in the session. I get the results. I fetch them. I built in this report object, and I return it so it can be used by the report. So this is how you register the report. You provide some information that will be shown in the helper, the details, the arguments that it has, just a brief description, and which reports you have available. This is an example of that report uptime that I was talking about. So here I'm checking the online helper for it, the syntax, description, and on the bottom, I'm running it using /show, and I get the report of my uptime. This is very nice, very useful, but the plugins are way more. It's something. It's totally different. It's much more extensive. It makes a shell very extensible, and you can write plugins. And in 8.22, we made this very easy to use, very simple, using annotations. So for example, here I'm creating a plugin. I call it system info. You can see the annotation at plugin that will indicate shell to create the system info class, the object. Using the Doxygen comments, you have the system info. I wrote that it's a system information, collection of tools to gather system information. And then using the annotation plugin function, I wrote this example to get the public key of my server. Gets a session, has the verbose mode, just a description. I'm not showing the code here, but just Python code to implement that functionality. And then you can run it very easily. The system info object is initialized within the shell automatically, like the DBA or the util object. You can access this helper using /? or /help. I have, for example, these three methods here: the get public key, the helper, the uptime. And for example, on the bottom, I run the get public key function, and you can see the output. So this is how you write a plugin. It's very easy, and you can use the whole set of APIs, including the admin API, for example, to write plugins. And you can do DBA operations, you can automate things, you can make it easy using these plugins for shell. Okay, just summarizing everything. MySQL Shell goal is to be the primary front end for most of MySQL functionality. It's an unified interface for developers and DBAs. It brings ease of use for complex tasks, and it's the front-end manager for InnoDB cluster and InnoDB replica set. And like I show you now, it's extensible and it's open source. I would like to share some additional resources. Just give it a try, download it from our downloads website. You should take a look at Lefred's collection of shell plugins. It's on GitHub, and Lefred says that he's very eager to receive pull requests. So go ahead, check, use them, try it out, and contribute. Also check our blogs. We usually blog about new features and what's going on. And you can reach us on Slack at any time using the MySQL community Slack. We hang out in the Shell channel and on the MySQL InnoDB cluster one. Okay, I have not much time left, but let's see if I have some questions coming in. Okay, classic one. Can MySQL Shell 8.0 be used with MySQL 5.7? Yes, of course it can, and actually that's the recommendation. You should always use the latest MySQL Shell version. It will work with MySQL 8 and MySQL 5.7. So yes, always use the latest MySQL Shell version. Another one, can MySQL Shell 8.0, no, should the DBA install MySQL Shell on his workstation or on the server? Why? Okay, I suppose this is related with replication architectures. And Shell can work remotely. If you're using MySQL 8, everything can be done remotely, including the configuration of instances. So yes, you don't need to install it on the server. You can run it remotely. But if you're using MySQL 5.7, when configuring an instance for a cluster or replica set, there are settings that need to be changed and that need to be persisted, and we don't have access to that. So you have to run it locally on the server. In MySQL 8, that's available because we have this amazing feature of MySQL, which is set persist, that allows us to change and persist settings remotely. So yeah, another reason to use MySQL 8.